Dear friends, our topic is complex numbers. What is a complex number? Let A and B are two real numbers. Then a number of the form A plus IB, in short we write it as Z, is a complex number. As for example, say 7 plus 2i minus 3 plus 4i, 2 minus 7i, 1 plus 0i, etc. are all the complex numbers. Real and imaginary parts of a complex number. Say Z is equal to A plus IB. So we find here two parts. One is this one, another one is that one. Now, real part of Z is equal to A and imaginary part of Z is equal to B. So we write an example, say Z1 is equal to minus 7 plus 3i. So real part of Z1 is equal to minus 7 and imaginary part of Z1 is equal to 3. Now a number, a complex number Z is purely real if the imaginary part of the complex number is equal to 0. Say Z is equal to 7. So here we find that this Z can be written as 7 plus I into 0. So since the imaginary part of this complex number is equal to 0, so Z is equal to 7 is purely real. Now on the other hand, if the real part of the complex number Z is equal to 0, then this complex number is purely imaginary. As for example, we take, say Z is equal to 3i or minus 3i, say. So these minus 3i can be written as 0 minus 3i. Since the real part is equal to 0, so this complex number Z is equal to minus 3i is purely imaginary. Now what is a set of complex number? See, the set of all complex number is denoted by capital C, and capital C is equal to A plus IB such that A comma B belongs to R. Since a real number A can also be written as A plus 0 into I, therefore every real number is a complex number. Hence, R is a subset of C, where R is the set of all real numbers. Now, we shall learn on another topic. These are respectively conjugate of a complex number. Next, we shall learn on modulus of a complex number. What is a conjugate of a complex number? Let Z is equal to A plus IB be a complex number. Then the conjugate of Z is denoted by Z bar, and this Z bar is equal to A minus IB. We consider another complex number, say Z1 is equal to X minus IY. Then Z1 bar is equal to X plus IY. It follows from the definition that the conjugate of a complex number is obtained by just replacing I by minus I. For example, say Z is equal to 3 plus 4i. So the conjugate of this complex number Z denoted by Z bar is equal to 3 minus 4i. Say another example, we take Z1 is equal to 2/3 plus 7i. So Z1 bar is equal to 2/3 minus 7i. This is the basic concepts of conjugate of a complex number. Now we shall learn on modulus of a complex number. What is a modulus of a complex number? Say the modulus of a complex number z is equal to a plus iv is denoted by modulus of z, that is this z is written in between two parallel lines and is denoted by this one, root over of a square plus b square. That is root over of real part of z whole square plus imaginary part of z whole square. Clearly mod z is greater than or equal to 0 for all z belongs to the set of complex numbers. As for example, if we take z1 is equal to 3 minus 4i, then modulus of z1 is equal to under root 3 square plus minus 4 whole square, that is root under 9 plus 16 is equal to 5. We can write this as plus minus 5 because modulus z is always greater than or equal to 0. So at least the value of modulus z will contain 0 or more than that. So now we shall use some properties of the modulus and conjugates. We have, say, z is equal to a plus ib, then what did we learn? Mod z is equal to root over of a square plus b square. Now if mod z is equal to 0, then we can write root over of a square plus b square is equal to 0. Squaring both sides, you will get a square plus b square is equal to 0. Therefore, a is equal to 0 and b is equal to 0. What is a? A is the real part of the complex number z. This is equal to 0, and b is equal to 0 means imaginary part of z is equal to 0. So when real part of z is equal to 0 and imaginary part of z is equal to 0, then modulus of z is equal to 0. Now we shall show another property. Let us consider that again z is equal to a plus iv. Then what is z bar? That means the conjugate of z. This is equal to a minus iv. Now we multiply both of them, z into z bar. That means a plus iv into a minus iv. What's the result? The result is a square minus ib whole square. So this one is a square minus I square b square. A square minus, what is I square? I square is equal to minus 1 into b square. So this one is a square plus b square. Now one thing is, z is equal to a plus iv. So from this one you are getting modulus z is equal to root over a square plus b square. Therefore, mod z square is equal to only a square plus b square. Now replace this one. So you will get a square plus b square is equal to mod z square using 1. So the rule is modulus of z square is equal to z into z bar. Have a nice day. Thank you.